It's my pleasure to extend a cheerful welcome to you all. I am Professor Mohammad Ahmad Qureshi, working in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. Today, we will learn mechanics of solids subject. Till now, we had learned about the introduction as well as the types of forces, characteristics of force, system of forces, and other principles. So now we will learn about triangle law of forces. What is triangle law of forces? How does it help in solving the examples of coplanar concurrent forces? So, first of all, the statement of triangle law of forces. What does it states? It states that if two forces P and Q acting at a point be represented in magnitude and direction by two sides of a triangle. This is first side of a triangle and this is the second side of a triangle. Taken in order, then their resultant, the resultant of P force and Q force, may be represented in magnitude and direction by the third side of the triangle, which is taken in the opposite order. So, now let us go for this law. Here, we have assumed that there are two forces, force P and force Q, acting simultaneously on a particle at point O. Now, as per triangle law of forces, these two force, which force? P force and Q force, can be drawn as the sides of a triangle. So this is your P force in this direction and this is your Q force in this direction. These two forces can be drawn as two sides of a triangle taken in order. Then their resultant capital R is represented by the third side, that is OB of the triangle taken in opposite order. Now, as per cosine formula, OB square equals to OA square plus AB square minus 2OA into AB into cos. What is the angle between P and Q? What is the angle between the two forces? It is nothing but beta. So here will be cos beta. Give this equation as notation 1. Now, what is beta? Beta is nothing but total 180 minus theta, where beta equals to 180 degree minus theta. Remember this formula, beta equals to 180 minus theta. Now, here taking OA as P, AB as Q, and OB equals to R. Now, from equation number 1, putting the values of OA as P, AB as Q, and OB as R. So equation number 1 will become R square equals to P square plus Q square minus 2PQ cos beta. Therefore, resultant force capital R equals to under root of P square plus Q square minus 2PQ cos beta. So, from this formula, you can easily calculate the resultant force from any of the given forces. Now, we have to find the direction of this resultant force. We have to find the direction of resultant force capital R. So, how can we find this direction? By using sine rule. Therefore, according to sine rule, OB, this portion, OB upon sine beta equals to AB upon sine alpha. Now, what is OB? What is OB? OB is nothing but capital R. Therefore, R upon sine beta equals to what is AB? AB is nothing but Q. Q upon sine alpha. Now, we have to find the value of alpha. Therefore, sine alpha equals to Q upon R into sine beta. Therefore, alpha will be sine inverse of Q by R into sine beta. So, this is nothing but your direction. You can find the direction of the resultant force by using this formula. So, this is your triangle law of forces. What does it states? It states that if two forces are P and Q, acting simultaneously on a particle, on which particle? Here we have point O. Then these two forces can be drawn as two sides of a triangle. This can be drawn as two sides of a triangle taken in order, and their resultant capital R is represented by the third side of the triangle taken in opposite order. And you can find the resultant force by using this formula. Capital R equals to under root of P square plus Q square minus 2PQ cos beta. And you can find the direction by using equation alpha equals to sine inverse Q by R into sine beta. Now, we will solve the example related to triangle law of forces. First example. Here, what is given? Two tensile forces. Both forces are tensile force. So, both forces are acting away from its point. Two tensile force, 20 kilonewton and 30 kilonewton, are acting at a point. The point is nothing but your O, with an angle 60 degree between them. Theta is given as 60 degree between P force and Q force. And we have to find the magnitude and direction of the resultant force. So, now first of all, we will denote the force is in some notation. So here P equals to 20 kilo Newton, Q equals to 30 kilo Newton, and theta equals to 60 degree. All the three values are given in the data. Now, we had learned one formula that what is beta? Beta is nothing but 180 minus theta. So, first of all, we will convert this figure as per triangle law of forces. So, here we are considering P equals to 20 kilonewton as one side. Similarly, Q equals to 30 kilonewton as the other side. But this side will be taken in the order of the triangle. And we know that the opposite side or the opposite order of the triangle will give you the resultant force. That is nothing but capital R. And angle between P and Q is given as theta. And value of theta is 60 degree. And we know that angle between P and Q in the inner side of the triangle will be your beta. So first we have to find the value of beta. Now, as per formula, we know that what is beta? Beta is nothing but 180 degree minus theta. 180 degree minus value of theta is given as 60 degree. So your beta will be 120 degree. So we had calculated the value of beta. Now we can easily find the resultant force. So we know that resultant force capital R equals to under root of P square plus Q square minus 2PQ cos beta. So putting all the values in this equation, value of P is given as 20 kilonewton. So here 20 square plus value of Q is given as 30 kilonewton. 30 square minus 2 into P. Value of P is 20 into Q is given as 30 into cos, and here we had already calculated the value of beta as 120 degree. So after solving this equation, we get the value of capital R as under root of 1900. And so finally, capital R equals to 43.58 kilo Newton. So after resolving the tensile forces as 20 kilonewton and 30 kilonewton, we achieved the value of capital R as 43.58 kilo Newton. Now, we have to find the direction of the resultant force. We have to find the direction of capital R. So, now for finding the direction, we will go through sine rule. Therefore, resultant capital R upon this angle sine beta equals to Q force upon sine alpha. Therefore, value of R we have already calculated here. What is the value of R? 43.58. So 43.58 upon sine, and beta is nothing but 120 degree, equals to Q will be your 30 upon sine alpha. We have to find this value. We have to find the value of alpha. So therefore 43.58 upon sine 120 is 0.866, equals to 30 upon sine alpha. Therefore, considering the value of sine alpha, here your sine alpha, so this will be multiplied here, and 43.58 will be goes in denominator. So your sine alpha will be 0.596, and therefore alpha equals to sine inverse of 0.596. So value of alpha will be 36.58 degree. So here we had calculated the direction of the resultant force, direction of the capital R. So by this way, you can solve the examples related to triangle law of forces. And it is very simple. You have to just use your basic two formulas. First formula is capital R equals to under root of P square plus Q square minus 2PQ cos beta. And for finding the direction, you have to go through sine rule. R upon sine beta equals to Q upon sine alpha. Now, let us go to the second example. Second example states that two forces, P and Q, are acting at point O as shown in figure. So here, one force is P and the other force is Q. Q is given as 80 kilonewton. And both forces are acting at point O. Find the magnitude and direction of the resultant force using triangle law of forces. Here we have to apply the same concept that we have used in example 1. So now first of all, we will start with the given data. So here capital P will be your 150 kilonewton. The second force is Q, and Q is given as 80 kilonewton. Value of theta is given. What is theta? Theta is nothing but the angle between the two forces. So this will be your theta. So theta equals to 45 plus 30. So your theta will be 75 degree. Now we have to find the value of beta. But where does beta lies? Here will be your beta. So beta will equals to total is your 180 degree minus theta. So 180 minus theta, and value of theta is 75. So after putting the value of theta as 75 degree, your beta will becomes 105 degree. So here we had calculate the mean value, that is beta. Now we will find the resultant force. So as per triangle law of forces, capital R equals to under root of P square plus Q square minus 2PQ cos beta. So putting the value of capital P, Q and beta in this equation, we will get 150 square plus 80 square minus 2 into 150 into 80 into cos 105 degree. So after solving the above values, you will get capital R equals to under root of 35111.65. So after solving the under root, we get capital R equals to 187.38 kilo Newton. So the resultant force as per triangle law of forces is 187.38 kilo Newton. Now we have to find the direction of the resultant force, that is direction of the 187.38 kilonewton force. Now we know that for finding the direction of the resultant force, we have the formula as per sine rule, capital R upon sine beta equals to Q upon sine alpha. Therefore value of R, we had already find the value of R as 187.38 kilonewton. So putting the value of R as 187.38 upon sine. What is the value of beta that we have find earlier? 105 degree equals to Q is nothing but 80 upon sine alpha. Therefore sine alpha equals to, after solving the above equation, you will get sine alpha as 0.412 degree and alpha equals to sine inverse of this value. So you will get alpha equals to 24.33 degree. This is nothing but your direction of resultant force capital R. Now you get the point for finding the resultant force and direction using triangle law of forces. Now we will go through the third example. What is given? A system of forces is made of two forces of equal magnitude. One system is there which is made up of two forces of equal magnitude. Here the magnitude is not given in terms of 10 kilonewton, 20 kilonewton or 30 kilonewton, but they say that it is of equal magnitude. Next, determine using triangle law of forces the angle between the two forces. Means we have to find the value of theta. If magnitude of resultant force, what is given? If magnitude of resultant force is equals to the magnitude of one of the force, means magnitude of resultant force, that is nothing but capital R, is equal to the magnitude of one of the force, means we have to assume the magnitude of both the forces. Then after assuming the magnitude of both the forces, we have to take the resultant force as magnitude of one of the force. So now let us go through the figure. Here we have assumed that this is P force and this is Q force, and the resultant force will be the diagonal of the parallelogram. So now, first of all, let us assume that let two forces are capital P equals to magnitude is not given, but we are considering as capital P equals to P magnitude and capital Q equals to what will be the magnitude of capital P? Here it is given that a system is made up of two forces of equal magnitude. If we are considering capital P as P, then your Q will be also P. And here it is given that if the magnitude of the resultant force is equal to the magnitude of one of the force, so your capital R will be also equals to P. What is capital R? It is nothing but your resultant force. Now, we know that as per triangle law of forces, capital R equals to under root of P square plus Q square minus 2PQ cos beta. So, what is the value of R? It is nothing but P. Therefore, P equals to under root of value of P is nothing but P, P square plus value of Q is also P plus P square minus 2 into value of P will be P and value of Q will be also P into cos beta. So after squaring on both the side, we will get P square equals to P square plus P square. It is nothing but 2P square minus 2 into P. That is 2P square cos beta. Therefore, P square equals to, we will take 2P square as common. So this will be 1 minus cos beta. Therefore, P square will be cancelled and these two will be taken denominator equals to 1 minus cos beta. Hence, your cos beta will be half, that is zero point 0.5. Therefore, your beta will be equals to 60 degree. So here we had find the value of beta as 60 degree. But what we have to find? We have to find the angle between the two forces. Between which force? P force and Q force. If capital R is equals to P, means we have to find the value of theta. So now, what is theta? Theta is angle between two forces. So 180 degree minus, this is your total 180 degree, and we had calculate earlier value of beta as 60 degree. So here your beta will be 60 degree, and 180 degree minus beta, that is 60 degree. Therefore your theta will be equals to 120 degree. So here we had calculate the angle between two forces, that is P and Q force, in which case in resultant equals to the magnitude of one of the forces. So here this is the simple law for calculating the resultant of the given forces. Triangle law of forces. So let us repeat the whole lecture. Simple triangle law of forces. It states that if two forces acting at a point be represented in magnitude and direction by two sides of a triangle taken in order, then their resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. And you can find the value of resultant force capital R equals to under root of P square plus Q square minus 2PQ cos beta, and you can find the direction of resultant force as alpha equals to sine inverse Q upon R into sine beta. These are the three examples that we have seen till now. In all the three examples, we had find the value of magnitude and direction as per triangle law of forces. So thank you. We will meet in the next lecture, that is based on other law, that is nothing but resolution of a force. Thank you.